Hey guys, welcome to part 2. Today we are going to talk about mole to mass conversions. So now, if some of these terms seem very similar to a pattern that we followed last chapter, it's because it is. It's almost the same pattern. You deal with moles, then you deal with moles to mass, then you deal with mass to mass. Okay, so we're using all of the same concepts from last chapter in this one. Okay, so I'm going to walk you through an example problem for how to do a mole to mass conversion. Okay, so let's say we've got a very similar situation to last time. We're producing table salt in a reaction with chlorine gas and sodium, right? Because table salt is NaCl. And so if we're reacting chlorine gas and sodium, we are going to get table salt. And we want to know if we have 1.25 moles of chlorine gas, how much table salt are we going to get? So we know, we know for sure that chlorine gas, which is Cl2, we have 1.25 moles of it. And we know that we're going to end up with table salt, NaCl, but we don't know how much. That's what the problem's asking us, okay? If you're following along, this is the example problem on page 360, okay? So let's write out a balanced equation. We know that we're taking solid sodium plus chlorine gas, and we are going to produce table salt, okay? Now, let's make sure it's balanced. Let's go through, double check. Okay, well, there's 2 of these, so there have to be 2 of those, which means there have to be 2 of these. There we go. Okay, all balanced. So we've got 2 sodiums plus 1 mole of chlorine gas will give you 2 moles of table salt. Okay, so now we want to write the mole ratio that relates table salt to chlorine gas because we're given chlorine gas and we want to know how much table salt. Okay, well, we use our coefficients again. So our ratio is going to be 2 moles of NaCl for every 1 mole of chlorine gas. Okay, it comes from our coefficients again. Now, we can first figure out how many moles we're going to have if we're going to have 1.25 moles of chlorine. So we do the exact same thing like we did in the last video. Okay, so we've got 1.25 moles of chlorine. And now we're going to convert. So we use our ratio. 2 moles of NaCl over 1 mole of chlorine. These cancel out. So we do 1.25 times 2. We end up with 2.5. I can almost hear you all reaching for your calculators. We end up with 2.5 moles of NaCl. So now we know that we have 2.5 moles of NaCl. But the problem doesn't ask for the moles. It asks for the mass, okay? So in order to find the molar mass, we use a periodic table, just like we always have, okay? So we figure out our molar mass of, in order to find out the molar mass of 1 mole of sodium chloride, we need to figure out the molar mass of each one, okay? So your mass of sodium is going to be 22.99, and your mass of chlorine is going to be 35.45. And so that means that your mass of NaCl, so mass of sodium plus mass of chlorine, is 22.9 plus 35.45. is going to give us a total mass of 58.44. So if this is the mass of 1 mole of sodium chloride, we need to figure out the mass of 2.5 moles of sodium chloride. So we do our conversion again, okay? So again, this equals the mass of sodium chloride because we did the masses of each added up. So that's our total mass of the compound, okay? So now we just use our conversion factor. We have 2.5 moles of sodium chloride as gotten from right here. This number travels right down here. Then we use our conversion factor, 54.44 grams to 1 mole. Cancel out our moles. Now we're left with grams. 2.5 times 58.44. Sorry, 58.44 is going to equal 146. If you round a little bit, 146 grams of NaCl. And so this is going to be our total answer because the problem was originally asking for mass. So if you're given something in moles and asked for mass, you start out by writing the balanced equation, always and forever. Then you can figure out your ratio of the two elements that you're trying to compare. Then you can figure out the amount of moles of the element that you want. Then you can move to calculating the molar mass of that element and converting the number of moles that you found to the molar mass. All right, so that is how you do a mole to mass conversion. Good luck.